We're going to have a look at this second worked example now. So this one's asking us to calculate the mass of ice lost from an iceberg melting if the energy supplied was 835 million joules. You might spot there's a bit of a problem here because our equation that we've used before, which is energy required, is equal to mass times by specific latent heat, doesn't have the mass as the subject of the equation. So I'm going to have to rearrange. Now, the way that I want to do that is I want to bring the specific latent heat over to this side. So I can see that I'm multiplying on this side. I do the inverse of that. So I'm going to divide this side of the equation by the specific latent heat. That cancels it out, but I've also got to do the same to this side. So I'm going to do the energy required divided by the specific latent heat. I'm going to just rewrite that to make it a bit clear. So energy required divided by specific latent heat is equal to the mass. I've now got my mass as the subject, which is what the question asked me to do. So I've now got my equation. I'm going to substitute the numbers in. So if I have a look for my energy required, that's the energy supplied, they're the same thing. So I've got 835 million joules. Because it's normally in joules, they're often very big numbers because a joule is such a small unit of energy. I need to divide that by the specific latent heat. Now, it's telling me that it's ice again, so I'm going to need the water in the table, and I'm actually melting the ice from an iceberg. So because of that, I know that it's the latent heat of fusion that I'm interested in, because that's when I've got an energy a change of state from ice into water or vice versa. So it's this number that I need this time. 334,000. And that will give me my mass. Because this is in joules per kilogram, it will give me my mass in kilograms. If this number was in joules per gram, it would give me my mass in grams. So the unit for the mass is consistent throughout the equation. All I need to do is put that into the calculator again. So 835 million. Be careful with the zeros if you've got a calculation like this. Divided by 334,000, and then press equals. So it gives me 2,500, and my unit is kilograms. So I've done the calculate, and then I've done the unit here. If this was a question in an exam, I may get a mark for the equation or the rearrangement of it, maybe a mark for the substitution, the calculation, and the unit. So make sure you've got all 4 of those in.